happens if we take out some negative charges from the center of the conductor, somewhere inside the conductor? When you take out negative charges, then you're leaving behind positive charges without the electrons there. So this region will have some excess positive charge. Now the question is, can this situation exist when the conductor is in equilibrium, that these positive charges are at the center, somewhere inside the conductor like this, when electrostatic equilibrium is established? What is wrong with this picture? Can you think about using Gauss's law to contradict this picture, to prove that this situation cannot happen when you're in equilibrium? It's the same argument as we did in the previous file, and we're going to make the same argument. So we're going to assume that there is extra positive charge inside the conductor, and we're going to assume that we are in equilibrium. Now, again, you can always use Gauss's law. Gauss's law is always valid. You can always make a Gaussian surface, and integration of E dot dA through this Gaussian surface is equal to the charge inside over epsilon naught. So let's make a Gaussian surface that surrounds the positive charge. The Gaussian surface is inside the conductor, but it surrounds the positive charge. If the conductor is in electrostatic equilibrium, what should the value of the electric field be at every point inside the conductor? From the condition of electrostatic equilibrium that the electric field is zero at every single point inside the conductor in equilibrium. And that means that if electric field is zero, then this term is zero, the left-hand side is zero. So what does that mean for the charge inside the Gaussian surface? The charge inside the Gaussian surface has to be zero. But this contradicts the assumption that we made before, that there was some positive charge inside the Gaussian surface. This means that this situation cannot exist in equilibrium. It contradicts Gauss's law. How can we get out of this? Now we know that the conductor, the material of the conductor is neutral, the original material. It has positive and negative charges. So if you add just cartoon picture of what's happening around inside the conductor, outside this Gaussian surface, this is the situation. You have positive and negative charges everywhere. So what will happen is that the negative charges that were in this region outside will be attracted towards the positive charges inside, neutralizing it. So the inside now is neutral, and now you have some extra positive charge over here. Can this situation exist in equilibrium, where you have these positive charges outside here, outside the Gaussian surface? It doesn't work, because you can make a Gaussian surface of a larger value, of a larger size, that encloses all of this positive charge. So the conclusion is, again, like with the situation that happened before, that you can never have extra positive charge inside the conductor. So where must this positive charge lie? The positive charge must lie on the surface. Now it's important to note that the positive charges inside are not the same charges as the ones on the surface. The positive charges haven't moved from inside to outside. The positive charges cannot move. What happened was that some of the electrons that were on the surface, they went inside to the inside of the conductor to neutralize the conductor inside. So these positive charges were always here. They never moved. But the end situation, it's as if you have positive charge on the surface of the conductor.